Hey guys, Mr. McKinney here, just doing a little follow-up video. This doesn't really go in 9.4. I'm not sure where it should go. This was an oversight on our behalf as teachers this year. We should have introduced this in a formal fashion earlier in the year. I've been talking about it a little bit during free response questions, but I wanted to record a video where I explicitly go through all of this. So this is the fundamental theorem of calculus. So as long as our function f is continuous and capital F is the antiderivative or the indefinite integral of little f, then we can find the value of a definite integral, which is an area, by plugging in the upper and lower limits into the antiderivative. So this fundamental theorem of calculus connects the indefinite and the definite integrals. It tells us how we can use the indefinite integral to find out the value of a definite integral. Now, what we're going to do in this video is we're going to manipulate this slightly. So here's our fundamental theorem of calculus, but I'm going to modify it a little bit. So instead of going from A to B, where A and B are both constants, I'm going to switch it so that we are going from C, which is a constant, to X. And then instead of F, I'm going to start with F prime. Now I can't make it X anymore since I have X as one of my limits. So I'm going to make it be T. So F prime of T dt. Now the integral of F prime, or the antiderivative of F prime, would be F. And then I could plug in X and I can plug in C and subtract. Now, we said C was a constant, so that would mean f of C is also a constant. X is a variable, so f of x then is an expression. So if I wanted to solve for f of x, I can just add that f of C over. So we can say f of x is equal to f of C plus the integral from C to x of f prime of t dt. We should have formally given you guys this in a video earlier than today. That was an oversight on our part, but you can use this formula from now on. And basically, what you should be thinking about is a future amount can be found by taking the initial amount and then adding the accumulated amount. So, for example, if I take the integral of velocity, that would tell me how much position or distance I had accumulated. So I could take an initial position and then I could do the integral of velocity to find out a new position or a final position. So again, this is just a different version of the fundamental theorem of calculus, but it's a common one that you'll see on the AP exam, to go from a rate to an amount. And they'll give you an initial condition and you'll use that to find the final amount, or an equation for the final amount, and then you can plug in X. The rest of this video just has this all typed up so you can make sure you have it easily readable in case my handwriting isn't that good. So again, if you want to know a future amount, you take the initial amount and you add the accumulated amount. And the accumulated amount is just the integral of the rate. Because the way I teach it in my class is we have amounts and we have rates and we have rates of rates. If I want to go down levels, I take the derivative. If I want to go up levels, I take the integral. So if I want to go from a rate to an amount, then I'm going to do an integral. A common example of this would be that a position, so x of t, is some initial position. It doesn't have to be at 0, it can be at any time. So x of c plus the integral of v prime of t dt, going from some constant, either 0 to x, or it can be any constant, to x. So this is the type of problem we've been doing on our free response questions recently, but it has lots of applications. And again, this is just a different version of the fundamental theorem of calculus. All right, hope this was helpful. Have a great day.